Hey there, this is Mr. Alexander, and I'm here to talk to you about laws of exponents and logarithms. Now, these exponential laws, this should be familiar from Algebra 1. Essentially, when you've got two bases multiplied together, you're adding the exponents. When you've got two bases that are the same and you're dividing them, you're subtracting the exponents. When you've got an exponent raised to an exponent, you're going to multiply those exponents. Anything raised to the 0th power equals 1. Anything to the first power equals whatever the base is. This should be review. The new stuff is the logarithm rules here. And let me just make this as simple as possible. Anytime you've got two logs of the same base, these are both base 10, these are both the common log because there's no base listed, and that's assumed to be the common log. Anytime you're adding together two logs of the same base, you can combine them into one log that is separated by a multiplication sign. So log of A plus log of B equals the single log A times B. Same thing down here. If you've got two logs that are the same base and they're subtracted, separated by subtraction, you can combine them, you can condense them into one logarithm where whatever the values of the logarithm are divided. And the last thing you need to know, and the best thing about logarithms, I think, is anytime you have a logarithm of some number that's raised to a power, you can bring that power to the front of the logarithm. That's the reason that we use logarithms. They cancel out exponentials. So essentially what happens here is you've got a logarithm of an exponential, and what happens with the exponent is it just comes out front. We're going to use that a couple of times here. I want to talk about simplifying exponentials real quick. Let's just talk about this Algebra 1 review. So I've got a few problems here I'm going to do, and I want to simplify. So I've got 4a to the third b squared times 3a to the negative fourth b to the negative third. The first thing you got to do is multiply the constants. 4 times 3 is 12. And then we've got a to the third times a to the negative fourth. So I've got an a. What I'm going to do with these exponents is I'm going to add them. So 3 plus negative 4 is negative 1. And now I've got a b. So I've got b squared times b to the negative third. And again, with these exponents, I'm going to add them. So 2 plus negative 3 is also negative 1. We don't usually like negative exponents, so we take this a little bit further. And now we're going to have a fraction. On top of the fraction is the 12. And on the bottom are going to be this a to the first power and b to the first power. And the reason for that is anytime you see a negative exponent, what it's saying to you is wherever the base is, whatever part of the fraction, the numerator or the denominator, put it on the other side of the fraction and then change it from a negative exponent to a positive. So you can imagine all of this is over 1, and we simply need to take that a and put it in the denominator, and take the b, put it in the denominator. And so a nicer way to write that would be 12 over a times b. Alright, here's another one right here. 4v cubed times v times u squared. So I've got a 4, I've got a v, in fact I've got 3 v's right there and 1 right there, so I've got v to the fourth, and I've just got u squared. So that one was a little bit easier. Again, just added the exponents. That was a 1 of an exponent right there. Now, I said it just a moment ago, whenever you've got exponents raised to exponents, you're multiplying. And this negative 1 is going to distribute to the 2, to the x, and to the y. So we're going to have 2 to the negative first power. X to the 4 times negative 1 is negative fourth power. Negative 3 times negative 1, that's y to the third power. So again, we don't like negative exponents, so I'm going to set up a fraction here. On top of the fraction, the only exponent that's not negative is that y to the third. So that's what I'm going to put on top of the fraction in the numerator. On the bottom of the fraction, I've got that 2 to the first power, or just 2, times x to the fourth power. So I changed that from a negative exponent to a positive. Alright, last one for exponents, then we're going to get to the logarithms. Whenever you get a nasty thing like this, first off, keep the fraction. On the top of the fraction we've got a 2, on the bottom we've got a 3. Same basis, when they're divided, you're subtracting the exponents. So we've got x to the 4 minus 2 is 2. And no matter what we get, we're going to go ahead and write it on the top of the fraction for now. Negative 4 minus negative 3, that's y to the negative first. And then negative 3 minus 4, that's z to the -7th. Now you'll notice that I've got some negatives on the top part of the fraction there in the numerator, so I need to move those down to the denominator. So on top of this fraction, in the numerator, I've got 2x squared. On the bottom, I'm going to have 3 y to the first power, or just y, z to the 7th power. Alright, so that was some quick 5-minute Algebra 1 review. Let's get to the Algebra 2 stuff, because you've never seen logarithms before. So let's talk about how to expand logarithms first. So I've got the log of 3 times 2 to the third, and I'm supposed to expand that. In this case, I can expand it into exactly 2 logarithms of base 10. Now, you can write the base 10 right there, but even if you don't, it's still assumed to be a base 10. This is the common log. So I've got multiplication. When I split this up, that multiplication sign is going to turn into a plus sign. So I've got 2 logs. Inside the logarithm is that 3, got the plus sign, and now I've got 2 to the third. Now you might be inclined to be done right there, but remember my favorite rule about logarithms is you can take that exponent and move it out front. That's what's so nice about logarithms. It gets rid of the exponents. That's their purpose in the universe. Their only job is to get rid of exponents. So now I'm going to take that 3 and put it out front. Okay, so log of 3 times 2 to the third is simply log 3 plus 3 log 2. Now, there's another way you could have thought about this problem by actually doing this multiplication. 2 to the third is 8, and 8 times 3 is 24. So really what I've got here is log of 24. Now, I challenge you to go to your calculator and type in log of 3 plus 3 log of 2 and see if it's the same as log of 24. I think you'll find that it is, and that's something you should probably do and check just to make sure I'm not lying to you. And just so you can see that I'm not lying to you, I went ahead and typed it in. Log of 24, log 3 of 3 log 2. They are the same. They're both about 1.38. So you might be asking yourself, which one's the right answer? Well, they're both right. We can accept both answers. But in the spirit, since the spirit of the problem was to expand it into more than one logarithm, this is probably the one you should write down, even though they're technically the same thing. Here, let's expand this. Now, here, I'm going to be able to expand this into 2 logarithms as well of base 10. They're common logs because of that one division sign. I'm going to separate them by minuses. But before I do that, I don't want that exponent up there. Remember my favorite thing about logarithms? We can take the exponent, move it up front. I can make this 6 log of 6 over 5. And now that that's out front, now I can expand. But when I expand, be careful, because the 6 is going to multiply to the entire thing. Log of 6 minus log of 5. And now you should go ahead and distribute the 6 to get 6 log of 6 minus 6 log of 5. Oops. Try to make that so you can see it. And so that's another way to expand with division becomes subtraction. Let's do another division one right here. Log of x divided by y to the 5th. I'm going to separate this into 2 logarithms separated by subtraction because I've got a division sign here. So that's going to be log of x minus log of y to the 5th. And hopefully you remember my favorite rule about logarithms. You can now take that exponent and just move it out in the front of only the second logarithm here, because that's 5 only applies to this log, not to that one. So it's still log of x minus 5 log y. So that's interesting. Depending on where the exponent is, see how in this previous problem the exponent was applying to both the 6 and 5, so then there's a 6 in front of both the logarithms. But on this second one here, the exponent was only on the y, so there's only one 5 in the final answer. So be careful about that. So we've been going from 1 logarithm to 2 logarithms, and you can expand it into 2, into 3. It just depends on how many operations are inside the parentheses of the original problem. Like if this had said times 3 divided by 4, then I could have had 3 logarithms there. Let's go the other way now. Let's talk about condensing from multiple logarithms into 1. The first thing we ought to do is recognize that this minus sign is going to become division. So I can rewrite this into one logarithm after I take care of these 4's. So that 4 is just going to move up there into the exponent because we can't condense them if there's anything in front of the logarithm. So I'm going to change this into log of 3 to the 4th power minus log of 8 to the 4th power. And I can rewrite that now into a single logarithm, base 10. And that's an important note. These things can only be combined if the base was the same. They're both base 10, but if that was a base 5 and that was a base 4, then you couldn't combine them in this way. But since they're the same base, we can do that. That minus sign is going to become division, so I'm going to have a fraction in here. I'm going to have 3 to the 4th power and 8 to the 4th power, which I can simplify that a little bit further, because 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. And 8 to the 4th power is 8 times 8 times 8 times 8, which is 4,096. Now, I'm not sure if I can reduce that, so I'm going to do in my calculator 81 divided by 4,096. Math, enter, enter. No, that can't be reduced. So this is the final answer here. Took 2 logarithms, changed it into 1. I've got here 6 log base 3 of u plus 6 log base 3 of v. So let's move this 6 out to the exponent here. And change this to log base 3 of u to the 6th. Now, that 6, you can write it inside the parentheses or outside. It doesn't matter. The effect is the same. I'm just going to write it on the outside since I wrote it on the inside in the previous problem. I wrote it there before, now I'm writing it on the outside. Not trying to confuse you, just trying to show you that you can write that exponent wherever you want, inside or outside the parentheses. Does not make a lick of difference. Alright, now I've got 2 logarithms base 3, got the same base, so I can combine them into 1 logarithm base 3, but now they're separated by a plus sign, so I can make them, when they're inside here, plus is going to become multiplication. So inside I've got u to the 6 times v to the 6, and you don't have to write the multiplication sign right there, but you can, and that's the final answer. Now you've been diligently watching my video for 12.5 minutes, so I'm going to give you some bonus problems here until we get up to 15. And thank you for those of you who watch me consistently and have subscribed to me. If you haven't, go ahead and hit the subscribe button right now. I'm just kidding. You can if you want. I don't really care. Actually, I do care. It makes me feel good. Anyway, I want to condense these log 2, log 11, log 7. They're all base 10. I want to combine them into 1 log. So I can change that into log 2 times 11 times 7. And hopefully you recognize you can combine that a little bit more, because 2 times 11 is 22. 22 times 7 is 154. Now that's one more condensing problem. And the big thing about condensing, remember, pluses change to multiplication signs when you condense. Minuses change to divide signs when you condense. Now when we're expanding, it's the opposite. So if you've got 1 logarithm with multiplication, then you're going to have several logarithms with plus signs. Before we can do any of that, this kind of goes back to last unit. Hopefully you remember that a cube root is simply an exponent to the 1/3 power. Cube root and an exponent of 1/3 are the exact same thing. So I'm going to go ahead and move that 1/3 out front, because that's my favorite rule about logarithms. And now I'm going to expand. Keep the 1/3 out front. I've got a log of x plus log of y plus log z. Distribute the 1/3. 1/3 log of x plus 1/3 log of y plus 1/3 log of z. As always, thank you for watching. I hope this has been useful. We'll see you on the next one when we're solving logarithms. Ooh, that sounds exciting. Have a good one.